You're listening to Impulse to Innovation. The Institution of Mechanical Engineers podcast. I'm your host, Dr. Helen Mees. As a global community of mechanical engineers with over 120,000 members in 140 countries, the Institution of Mechanical Engineers has been at the heart of the engineering profession since 1847. The institution's mission is to improve the world through engineering by sharing the latest news, views and insight into the creative world of technology and the people that make it happen. This month's episode is all about communication. Very apt for a podcast show. The world of wireless communications has come a long way since Bell and Tainter first conceived the photophone in 1880. Today, we are literally surrounded by radio waves, and it's believed that from that first intentional radio signal we sent into space in 1974 from Arecibo, our radio echoes can be heard across the galaxy, some 100 light years away from Earth. But the social revolution that occurred in the 1990s, triggered by the development of digital wireless networks, is now part of the norm of our everyday lives. And indeed, without such systems in the last year, isolation and lockdown would have been even more unbearable. Today, wireless communications and our connected devices dominate our lives. But what are today's engineers working on that could possibly improve our data-driven lives of tomorrow? My guests this month are Dr. James Flint, Professor Misha Dola and Rick Hanks. They share their thoughts on what wireless networks and communications means to them and their anticipation of what is to come in the future. James Flint is a chartered engineer with the IET, reader in wireless systems engineering and Deputy Associated Dean of Teaching at the Wolfson School of Mechanical, Electrical and Manufacturing Engineering at Loughborough University. His research focuses on various aspects of wireless systems, and currently he's working on novel computing for sensors, the Internet of Things, and energy harvesting. He also has a keen interest in biomimetics, ultrasound, and on converting systems found in nature into workable engineering solutions. I started by asking James about the advances in wireless systems and how wearable technology has become an everyday part of our lives. James, welcome to the podcast today. We are becoming more and more dependent on wireless systems, aren't we? And that must be causing engineers a number of challenges in terms of how they can innovate in this space, especially on where and how they place devices. You've been particularly focused on wearable systems, haven't you? So could you tell us a little bit about what wearable wireless technology is?
Yeah, sure, Helen. I mean, you say dependent. I mean, mobile phones are not really phones at all anymore, are they? They do so many other things. So you've got fitness trackers and you interface to the internet using those things. You control your environment. There's just so many different things that you do. And there's lots of problems created if you want to use mobile devices, even just dealing with a mobile phone, if you like. So these days, the issues are really a lot around miniaturization. So having things that are small enough to fit in spaces around us, even within the mobile phone device, the traditional mobile phone device, if you want to add a new technology in there, it has to be really tiny because you still have to carry the thing. So yes, there's so much work going on in making devices that are wireless fit inside existing devices that are around and fit inside things like clothing and that sort of thing. So wearable wireless technology, I guess, is a subset of this. So the idea of wearable is that it should just be in the part of your clothes that you wear every day. So rather than making a conscious effort to sort of balance your mobile phone on your hand, it's built into the clothes that you just naturally put on, and it just interfaces seamlessly into your everyday life. And I guess that's what's really exciting and interesting about this whole idea of wearable wireless technology.
Yeah, for me, carrying lots of bits of kit around as I do, particularly when I'm doing things like podcasting and stuff, to be able to have something that fits into my clothing or easily into my everyday life would be so much easier. I'm guessing this is something that is going to develop over the next few years. Now, as we start to integrate this wireless technology into textiles for clothing, for example, glass for spectacles, we're starting to see that sort of thing happen, and even furniture. We need to consider things like the profile, the weight, the portability of these devices, don't we? So how are engineers approaching this? Is it changing the way you apply things like manufacturing methods?
A lot of the advances are driven by material science. Because if you want devices which are going to be worn, for example, or fitted inside a piece of everyday furniture, you've got issues like moisture capability, whether it absorbs water. You need high performance materials to make them small. You need good manufacturing techniques. Sometimes you may need it customized to the person. I mean, there's a very big movement at the moment in making tech a lot more aesthetic as well. So having wearable technology is starting to bring in more textile designers, for example, who now are interested in this area. And as the technology becomes more ubiquitous, the design space is being explored a lot more actively. So making these things look nicer and behave more naturally around us. So it's getting to be a very, very multidisciplinary area, wireless. When I first came into it, it was all about bits of wire and making things that radiate. The sort of the TV antennas you see on your roof.
Yeah.
Now, we don't want to see them. When I was in automotive 20 years ago, there was a very big move towards antennas that were just integrated into the glass around a car. And that was, if you're old enough to remember that was a very big change, because previous to that, most antennas were on the outside and they were obvious.
Yeah.
People don't want to see antennas. They want the functionality of having wireless, but they don't want to see it. And that's a really exciting thing, actually, because it means people use it and they appreciate it, but they don't need to know the technology.
Certainly from my experience, the growing movement for wearable technology, particularly in the aging population, that demographic has made it very clear to engineers and designers that they don't want technology on show. They don't want to be identified as an older person. So they need that technology to be integrated, don't they? And to be hidden away so that they can feel comfortable with using it.
And it's all about accessibility, isn't it? I bet there are lots of people who were not happy using computers that now readily have an iPad and don't even think of it really as a computer. It's just a device. It's like a newspaper or something else that people were familiar with. So that for me is an exciting thing about tech. It's people who aren't interested in tech being able to use anything.
Yeah, I would say my dad is one of those sorts of people. He's 82 now, but he's very happy with his PC and his tablet and his mobile and wouldn't be seen anywhere without any of them. Now, we can learn a lot from the natural world when it comes to things like acoustics. And this is something that I know that you're very interested in, James. So can you tell our listeners about the work that you've been doing in biomimicry and how that relates to telecoms?
So, for a very, very long time, natural organisms have developed sonar, for example, and an ordinary hearing, in the sort of range that you or I would think of as being hearing. Things like bats and dolphins able to echolocate, to detect prey, and they do a lot more than we would do with our vision and hearing. They're a lot more active in that area. So there are some very complicated structures found in nature that deal with sound transmission and sound reception, and they do things which historically have not been possible in electronic form. Some very, very detailed sonar detection tasks, etc. And at the very least, we have to work very hard to do the same thing that some of these organisms can do, just as a normal sense. So I've been very interested in looking historically about how some of these things work. If you like, reverse engineering nature, reverse engineering, understand what the animal is doing, and then trying to take inspiration from that. So bio-inspiration is the term that most people tend to associate with this. Rather than true biomimicry, it's being inspired by the mechanism. So what's happened historically? So for example, a dolphin, on the dolphin's head, there's a shape. It's almost like an acoustic lens that changes. It beamforms the shape of its sound that's outgoing, that then strikes its prey, and then it enables it to feed. So this whole idea of being able to beamform using this very large piece of its body, which is called a melon on its head, is something which has been used now much more commonly in the form of an antenna. So there's lots of things to learn about this. Bats also echolocate, or they look for their prey using outgoing sound and their hearing. And yeah, so there's many sorts of things that are there to take inspiration from. And in terms of telecommunication, acoustic devices are perhaps a little bit more familiar to us. So when we know about things like echoes when we're talking in rooms which have got big flat walls, we know all about those things and we're familiar with that, and lots of animals do that. In terms of electromagnetics, which are involved in wireless communications, we're perhaps a little bit less familiar, and there are some organisms that use electromagnetics outside of the optical spectrum. But on the whole, that's a rather unexploited area in nature. But maybe we can take ideas which come from sound and translate them more into electromagnetics and communication. So some of the techniques which are used for sound can also be used inside antennas and communication systems.
It's very exciting. It sounds like a real opportunity to understand what's going on in the natural world a lot more, and to find lots of different ways of providing communications that perhaps we've not considered in the past, but also that could be more diverse and more inclusive to society, to enable different people to use those technologies.
As an area, I find bioinspiration, biomimetics a very exciting one, because it makes a good link between an engineer and biology. So you gain a lot through learning about nature, and being able to take that and go into engineering space is a really nice interface. It gives you a great sort of vision of how everything works, and it keeps you grounded in what really matters. I care a lot about the environment, and when you're working in communication systems, conserving energy, which links back to sustainability, the materials you use, and making sure those materials are sustainable. That's all part of a spectrum of the type of engineering that excites me.
And it's certainly an area that we don't consider when we think about wireless and communications. We don't necessarily think about energy conservation and sustainability. So that's nice to hear you talk about that in terms of your responsibility as an engineer. Now, when I think of future wireless comms, I think of a show that I watched a while ago called Years and Years. I don't know if you've seen that. If you haven't seen it, I definitely recommend it to our listeners. There's one of the characters in that series who wants to become a transhuman, to ultimately become data. And to achieve this, she starts to have her body augmented initially with her mobile phone and internet connection. Now, this, of course, is a long way off, I'm presuming. But looking to the future, what impact do you think the work that you're doing at Loughborough could have on the way we engage with wireless systems in the future? And do you think that things like flexible antennas and biomimicry might actually become part of an augmented human future?
We've sort of moved there a bit already, haven't we? When you look at the way that, even at the moment, when people are often glued to their phones, not literally, but sort of metaphorically, they're glued to their phones, and things happen very, very quickly, don't they? I mean, you only have to watch what happened with the insurrection in the US and all the things that happened after that event, and how very quickly things travelled around the world straight from one Twitter account.
Yeah.
And so we're kind of getting there already. And it's a lot of it is about the interfaces, isn't it? That's what's really changing. And that's where the development areas are. It's slightly worrying in some senses, but actually it's really exciting that the sort of line between the device and the human is getting more blurred. For me, though, it's not about speed or any of that kind of thing, or integration of the human. It's about making it very, very smooth.
Yeah.
Yeah, so it's about making the experience of operating the devices almost transparent, and that's an exciting thing that can be brought with these wearable systems, and by using good technology that's small, it doesn't sort of take any space up, and is light, and you naturally want to use it, and so that's where I think things are going. It's the interface between the human and the device, and there's no longer this glass wall. I think what we've seen in mobile devices, there's been a move towards more flexible screens, which is a very important technology if you're going to make it natural. But many of us are still walking around with these sort of chocolate bar antennas that we look at, which are quite hard. And that is that wall that sort of needs to be broken. And wireless, biomimicry, the aesthetic angles of wireless are the things that will make that happen much more rapidly in the next few years.
So you don't fancy having one of these antennas inserted somewhere under the skin then?
No, I've had that threatened before, but that's not what's going to happen, hopefully.
That's wonderful. Well, I really was taken by this whole idea of ultimately becoming data, and not necessarily me personally, but maybe, these things will happen in the future. James, thank you so much for taking the time to talk to me today. It's really fascinating to hear about the work that you're doing, and particularly how the natural world links to this wonderful world of telecommunications that we are so now bound up in as a society. Thank you ever so much.
Thanks for inviting me, and all the best for the show.
IMechE Dola is Professor in Wireless Communications at King's College London, driving cross-disciplinary research and innovation in technology, sciences and the arts. He is a Fellow of the IET, the IEEE and the Royal Academy of Engineering, as well as being a serial entrepreneur, composer and accomplished pianist. He is passionate about changing the way we interact with telecommunications and wireless systems through tactile and haptic technology, and is pioneering various novel concepts which will become reality with 6G. I asked IMechE to explain why he was already working on 6G when 5G was only just being adopted. IMechE, thank you so much for taking the time to talk to me today. I'd like to start really by asking about mobile and broadband networks. Now, most of our listeners will have heard of 5G and how this fifth generation technology standard will give us greater bandwidth and higher download speeds. But you're already looking way ahead of that, aren't you, in your research to 6G. So can you tell us a little about what 6G will offer us in the future and how it might change the way we communicate?
Right, Helen. Yes, nice to be here with you. Well, telecoms has evolved in wonderful trends, and it seems we can't break it. So every time as we go from 2G, 3G, 4G, then 5G, now 6G, something always improves by an order of magnitude, right? Or two orders of magnitude. So just look at the average data rate you experienced, in 4G. It's something like 10 megabits per second. In fact, it is so good that you completely forgot that you're not anymore sitting on a fixed network, right? So you're walking around, nobody looks at the 4G logo anymore like we used to look at the 3G logo because the network has become so good. Now in 5G, we multiply that by 10. So now it's 100 megabits per second. So, whatever it is, Skype, Zoom, better quality, or you have augmented reality, virtual reality, you can do really stuff we couldn't do with 4G. Now 6G, we suspect will be the same thing. So we multiply what we had right now in 5G, 100 megabits per second by 10. So we're going to expect something like 1 gigabit per second. And the same happens with all the other what we call key performance indicators. So latency goes down. So the time it takes for the system to respond when you click on a link and you get an answer back, on 2G, it was a disaster. It took like a long time.
Yeah.
It got better and better. And then in 4G, you start to forget about it. And in 5G, you don't even notice. It's better than your Wi-Fi, right? And in 6G, we're going to push that even further. And interestingly, people always ask me, hey, IMechE, why do you start so early? And it's actually, if you think about it, quite late. So in 5G, you heard about it now, maybe last year, first time about 5G. We started in 2012, 2013 to really talk about 5G. So it takes us a long time to design these systems and then be able to design technology which multiplies, these technical KPIs by a factor of 10 or 100.
I absolutely agree. I mean, I'm old enough to remember, sitting and waiting for modems to kind of chug through information. I think young people today don't really understand how quickly data is presented to them. As soon as they press that button, it's there. So yeah, I can totally understand how it's just going to really revolutionize the speed at which we can send data and send information to us, and the amount of data as well. I suppose we're consuming so much more data now than we were even 5 years ago, aren't we?
Yeah, no, it's a good point you're raising, Helen. And I think personally, that's an observation I've just made recently. Is I think we have really hit the limit of how much data can be shipped around over the network from a human consumption and production point of view. I mean, you can only make so many TikTok videos and consume so many TikTok videos
Yeah, right.
because our day has only 24 hours. So, and if you look at it from a scientific point of view, we talk about data density. So how many bytes or bits are being produced per second per square meter. Okay. And I think in 4G, we're already quite close to the limit. 5G definitely has hit the limit. So the big question is, why do we need more? And I suspect that we will have, machines. We have a lot of autonomous decision making now in networks, a lot of AI, artificial intelligence taken over. It sounds very frightening, and maybe it is frightening. I'm really not sure. But we try to keep it under control. The whole AI, the rise of the AI, and but there's clearly a new client, a new kid on the block, which needs a lot of data to be shipped forth and back. And these are these machines, that AI, and they will coexist with humans watching TikToks and doing all these things. So I suspect a lot of that extra data capacity we are building as part of the 6G roadmap will be precisely for that type of user, if that makes sense.
Yeah, it's not going to be for us as humans, is it? It's going to be for the machines that are going to be able to process that data far
Yeah,
faster than
yeah,
we can even interpret it. So
yeah.
yeah, absolutely. Now that leads me on actually to my next question. When I began reading about the work that you were doing, I was absolutely fascinated by the research that you're working on, not just on the Internet of Things, but the Internet of Skills. Now, this combines audio and video communication with the transmission of touch. And you describe this as the opportunity to democratize global labor and wealth. It's quite a bold statement, really. As I understand it, this kind of technology is starting to appear in certainly in the healthcare sector, where you have things like robotic surgery, for example. But iOS is a technology that could significantly change the engineering sector and certainly the manufacturing industry. So what kinds of technology will be part of this Internet of Skills? And what impact do you think that's going to have on the workplace and the workforce?
Yeah, that's a great question. And, it is really my passion. It's my baby. We're talking about my baby now, the Internet of Skills. And, you need, to answer your question, you need three ingredients. We have them here and we have them now. And that's why I started working. So we do need, of course, robotic edge equipment, exoskeletons. I'll explain in a moment. So robotic needs to be at the stage where we can use it really in conjunction with humans. We do need very, very powerful networks, very low latency, and I explain in a moment as well. And you need artificial intelligence to be strong and solid enough to deliver, certain aspects of the system. So these are the three ingredients: so network, robotics, and AI. And when I had the vision first, it was 2013-14. I realized it didn't make sense for our doctors to travel the world. They could have perfectly stayed in London and done, let's say, a robotic surgery for somewhere else. And I started talking to Prokar Dasgupta, who is a colleague of mine, a wonderful personality. You should have him on your podcast show, by the way. And
Okay.
he's a pioneer in robotic surgery. And I said, Prokar, what do we need to make this happen? And one thing they really struggled with was this feeling of immediacy. Okay,
Yeah.
so when two humans meet, or when a surgeon does something, or when I play the piano, you play the guitar, or somebody paints, there's that feeling of immediacy. The moment you decouple both ends, you have a bit of latency, right? So
Yeah.
it is only when networks become so low latency is that you get the feeling that you're actually doing something, as if it's immediate, even though it might be over very large distances.
Yeah.
That's why I needed 5G. 5G was the first network which was able to bring this latency below that psychological barrier of 10 milliseconds. Because anything which happens below that bound, we think it's in my brain, our brains think this is like immediate, and they start to get fooled. And they think it's happening right now, right here. So we needed that. Okay, so 5G, tick, that was done. Then we needed soft robotics. So Hong Bin Liu, a good colleague of mine, invented a lot of soft robotic equipment because you can't have these big Iron Man suits walking beside humans. That happens in Hollywood films, but 2021 in a real setting, you can't have it. So we need something softer. We have done that as well. That's great. But then we still had the problem, when we look at distances, London to Los Angeles, speed of light is still something like 40, 50 milliseconds, right? So therefore, what can help us to bring this down to 10 milliseconds? I went to the physics department. I asked them, guys, can we do something about it? Can we break the laws of physics? And they said, Misha, I'm just kidding. I didn't do that, right? So I'm a physicist by education, so I knew we can't do that. Anyway, so we figured out we could use AI, which does a lot of prediction on both ends. So AI would understand what's happening in London. Let's say Proka is using his surgical tool in a certain way as he has been doing for the last 20 years. AI is able to predict that. And then on the other side, in Los Angeles, they know that Proka now is moving this way. And then on London side, the AI will predict how Proka's cutting through whatever he's doing. The operation, the surgery will actually will be playing out with the patient or with the environment, whatever, So therefore, we're using two AIs predicting each other, and therefore we don't need to send over all that huge amount of data. We can perform that remote surgery with a feeling of immediacy, both for the patient as well as for the surgeon. And this is where I put it all together. And I coined it actually, Internet of Skills, indeed, because I wanted to transmit not only touch, but also muscle movement.
Right.
I wanted you to be able to move things through the internet. I wanted you, I want to teach people how to play the piano. You can teach me how to play the guitar, right? So this is not only touch, this is actually a lot of kinesthetic movement which needs to go through. And I realized that we can do any skills, anything what anybody has a skill. And I gave it the name Human 4.0 because in the industry world, we call something Industry 4.0, meaning the automation and the empowerment of machines. And I thought, why do we empower machines? I want to empower humans. So I created that Human 4.0 Internet of Skills, if that makes sense.
It sounds an amazing opportunity particularly for the engineering community. It gets me excited thinking about it. I work in that healthcare field, so I'm very familiar with the haptic feedback and things that are going on in robotic surgery. But to think about how that might be used in other fields. In last month's podcast, we were talking about resilience and being able to look after our infrastructure remotely. And I can see the implication for this kind of engagement with humans and machines, being able to feel and touch things that are hundreds of miles away could have a real impact on the way that engineers build and develop technology in the future.
Yeah, totally. I mean, you could think of, the most creative people without needing to travel, they would actually do prototyping together and very hands-on prototyping. Because currently we can only do that with, platforms, online platforms, which is not the same. So you're translating this back into the physical setting without actually doing the physical setting. We can think of totally rethinking how, products are being brought to production, how products are being maintained, serviced, so the entire life cycle, even then the recycling and the decommissioning, the entire product's life cycle could now be done in a very distributed fashion in the same way as the internet works, but now transposed into the real world.
That's amazing. I'm really excited, and I will be following very closely the Internet of Skills over the coming years. So I look forward to seeing more of that. Now, I couldn't finish this interview without talking about your music composition, Misha. For the benefit of our listeners, Misha is an accomplished pianist, having produced 5 albums and played over 10 worldwide performances. I'm going to put a link on our podcast website so you can have a listen to some of his albums. Now, obviously, music plays an important role in the work that you do, and you recently published a paper on the first 5G interactive music concert, which took place at 3 different venues over 100 miles apart. What benefit do you think the internet and wireless technology offers when creating this kind of sort of large-scale public performance?
Yeah, so I think there are two aspects to that question. So the first one is, in general, why would we engineers bother to do that? Let's say artistic cross-disciplinary design. And I've really taken this into my DNA because I want to become actually a professional pianist. Ended up in engineering is a long story on its own, but here we are. And in a nutshell, I felt this. What we lack as engineers often is to give our technology some soul. And doing that cross-disciplinary, whether this is now with, within the arts or transport or medicine, you give it context, you give it soul, you give it, societal application. People know immediately what it can be used for. And I think we need to do more of that. We need to teach more of that at schools and at universities, because what is the use of having brilliant engineers designing fantastic things if they're not able to communicate that? We need to teach that because then society really understands the value of this. And this is really what I wanted to do with that. And specifically, we had pioneered this whole notion of 5G, low latency distributed concerts, because we had this very low latency in 5G. And I understood that it could give us the same kind of experience as if you're on stage, because sound travels much, much, much slower than light, right? So once you had put it on electrical signal, we could cover much larger distances and still give the feeling as if we are on the same stage, right? And we did that. In fact, we did it with my daughter, with my older daughter, who loves to sing. And she actually sang with Madonna on Madame X when she released it last year. So
wow.
She's really into music. So we had her in London. I was playing under the Brandenburger Tor, and that performance was so emotional, because Noah was like with me, right? So she was with me. She was not over a Zoom call. She was not over a Skype call. She was with me, emotionally connected, because we were at a latency which nobody has seen before over these distances. And I really struggle, not to cry during the performance, because I just got so overwhelmed by these emotions, and this is really what we want to do. We want to be able to give people these emotions with a commodity technology. We don't want people to pay a fiber which costs millions of dollars. We want them to use a commodity technology called 5G. It's still very sparse, I agree. But, in 3, 4, 5 years' time, everybody will have it. All the musicians, you can talk to your parents, to your children. It will be this all-encompassing, Zoom plus, whatever you want to call it, where we are able to use the digital medium to still get emotions we can't get today. So therefore, I think it's important. And we did the first baby steps. And I think now we leave it to the community to be creative, what could be done on these platforms.
Well, as a musician myself, I am really excited by that opportunity. Over the last 12 months, it's been impossible for me to play with my band and with other musicians. And the only way we've been able to share our music is to pre-record it and play it over the internet. So the idea of being able to play together at long distances would be a wonderful opportunity. So I absolutely agree with you. The opportunity to be creative with technology, I think, is going to be something that engineers really need to get into over the next few years. IMechE, thank you so much for joining me today. It's wonderful to see your passion and your enjoyment for the subject that you're working in and for the work that you're doing. We really look forward to seeing more from you in the future. Thank you very much.
It's my pleasure, Alan. Thank you so much for having me.
Rick Hanks is a smart metering lead and industry innovation principal director at Accenture. He has extensive experience of implementing digital transformation, smart metering and business change projects within the utilities and communications sector, and is leading the design of the smart metering communications infrastructure across the UK. Rick is fascinated by the way in which wireless communications can change the way we use our energy resources, and shared with me his thoughts on what other technologies might benefit from wireless connections in the future. Rick, thank you ever so much for joining me today. I mentioned in my introduction, your work focuses predominantly on smart metering. Now, as I understand it, there are 22.2 million smart meters in operation across the UK. So most people will be familiar with one of those little units that sort of measures their electricity and gas usage. But for those that are not familiar with how this technology works, can you give us a bit of an idea of what these devices do?
Yeah. Hi, Helen, and thank you for giving me the chance to talk to you today. So smart meters, 22 million seems a big number. In fact, we're only halfway. There's going to be 50 million of these things in our homes by the time we finish. And smart meters started probably getting on for 20 years ago when we first started thinking about putting these in people's homes. And that was where the beginning of thinking about climate change and carbon reduction and how do we live more sustainably came across. And smart metering is there to enable us to measure the energy in our homes. So if you look at the energy that we use, it's transport, it's heat, it's cooking. And a big chunk of that will be the energy in our houses. And up to 20 years ago, and in a number of cases still, they're manually read meters. Now, if you want to change customer behavior and enable people to understand how much energy they use and therefore how to use less, you need to measure things. And if you can't measure them, can't change. So smart meters were essentially the idea to give people feedback and information about how much energy they are using on a day-to-day or a minute-by-minute basis. So real-time feedback loops to customers so that they know how much energy they're using. And most people say to me, Rick, I never knew I was using that much energy until I got a smart meter. And oh my God, now my husband is a right pain because he goes round and turns all the lights off.
Yes, my husband does the same.
Exactly. That's fundamentally what smart metering was there for. Okay. It was designed to give customers the ability to understand how much energy they use and therefore enable them to use less. But it's also had some other, major benefits that really come out. So if we measure energy, it means that we can provide that energy usage into analytics algorithms. And we all know USwitch and go compare, those sort of things. And really what that is enabling us to doing is to take our usage patterns over a year, feed them into those organizations and say, what's the cheapest tariff? How do I save money? So not only am I saving energy, but I'm also saving money on my bill. So it enables competition. So that's another way that smart meters help. But also, if you think about, 2000, pay-as-you-go mobiles came about and absolutely transformed the mobile market. So SIM-only deals where you pay as you go. We can do that for energy now. So on our mobile phones, we have apps where we can buy energy instantaneously and send that money essentially to our meter at home. So pay as you go has moved from having to go to the corner shop to top up to actually now doing everything. And it becomes a lifestyle choice as opposed to something that was maybe imposed on you because you were at the vulnerable or fuel poor end of the market.
Well, certainly we have a smart meter in our house, and it has, as I said, made a big difference to us and our electricity use. So really, the technology that came out of the mobile phone and that telecoms industry has actually benefited this device, which otherwise we wouldn't have been able to collect that sort of amount of data, would we? And understand what's going on nationally and internationally in terms of our energy use. So telecoms has really made a difference to our energy consumption.
Oh, for sure, for sure. I mean, communication is critical to it, and we do see that initially the smart meters going in, they either use private radio or they're on the GPRS or 3G networks. But as we see people wanting more and more data, people never want less data. It's always more, and now we're seeing actually the need to change your communication methods to increase those data throughputs, to get more and more data to the customers so you can understand things in more detail, means you need to increase your communication capability. And we see that. So, for example, if we look at usage patterns where actually now we can measure your energy usage in real time and determine which of your applications in your house is running. So am I running my fridge freezer? Am I running my washing machine? We can provide that data back to analytics, which can tell us what's failing. Where am my data usage going? Am I using all my power shower? And this really helps customers both understand their energy usage, but also maybe preventative maintenance as well around those assets.
Well, that leads me on to my next question, really, because previously on the podcast, we've talked about the importance of net zero and the resilience of our energy infrastructure. But smart metering isn't just about monitoring personal energy use, is it? It could have potentially wider implications in terms of energy demand outside the home, like things like electric vehicles, for example. So what kind of things could smart metering help us with, and why is that important, and how is that going to fit into this whole Internet of Things?
So if you asked me 10 years ago, what were smart meters for? And I would have said they're to optimize the meter to cash process and help consumers understand their energy. Today, we look at smart meters very, very differently. So we have used our electricity network the same for generations. But now we're decarbonising transport. So electric vehicles, they are going to be plugged into the network at home, and they are going to change the amount of energy we use in our home. Also, solar panels. I have solar panels on my roof, so I'm actually a net exporter during the day. The electric vehicle at night means I am sucking power in. And that means we're putting the network under stress. So the distribution network, which has been designed to be stable, essentially to have power from large power stations flow through the network to small energy users, is now having me as a small energy generator as well as a consumer. And that's changing the way that the electrons are flowing around that network. And normally, because things were stable, distribution businesses did not measure and control the network at this lower level, at the connection and the low voltage level to my house. But now I'm messing with the way that I'm using the energy. And that means we need a lot more information about how that network is coping. And therefore, smart meters, being at the end of the network, are a fantastic source of information on how that network is running. And actually, what I'm now looking to do is not only measure kilowatt hours for billing, but I'm also looking to measure voltage. So can I measure the voltage? Because that's a very key indicator of whether my network is running under stress. So that's initially just a measure, okay? So I now know what's going on my network. But if I am putting my network under stress, I want to be able to control the energy flowing through it. And therefore, my electric vehicle, especially if I've got a fast charger, is taking a lot of power out of my network. And therefore, I want to be able to control it. So is there a way that I can use smart meters to control the power flow to my EV charge point? And the answer is, in the future, yes. So we're actually going to see smart meters move from being just assets that monitor the network in terms of kilowatt hours to actually being an integral part of how I manage my network and how I manage my electric vehicle charging.
So all of this is going to be accessible to the user themselves, but also the energy supplier. They're going to be able to analyze this data in huge data sets, I suppose, aren't they? So the communication of that information is going to be extremely important in terms of sharing the understanding of what's going on in society in terms of our energy use, and tying that all up with our wireless networks is going to be really quite important. Do you think it's going to put a lot of strain on our wireless systems and our telecommunications?
It's definitely going to change the way we use it. So if you just think about us as consumers, we like convenience, right? We're always unconnected. My children track me around wherever I am through my phone. I'm always connected now, and we're going to see the same thing for our energy usage. So you can imagine you buy a new electric car, and every mainstream manufacturer has an electric car. And we're seeing the utility companies join forces with those EV car manufacturers now, because actually they want to sell you an electricity package integrated with your vehicle, which means I now actually want to manage my electricity usage irrespective of where I am. So I'm no longer within the home having an energy bill. It's me. And I'm charging my car when I go to the supermarket. I'm charging it when I'm on the motorway. I want one bill. So I'm now tracking my energy usage through that always on connected. And we are going to see this much, much more, that people start being fully integrated into their energy usage. And we'll see that drive more potentially carbon accounts. So maybe I'll have a personal carbon account, which I track on my app. that is not only using the car and the electricity, but potentially I'll link it into the food that I'm eating, and suddenly, I'm fully integrated. But you said, is this going to put the network under stress? No, in simple terms, it's not going to put it in stress in terms of capacity, because I'm not streaming video, so I'm not hitting it for that area. But what it will put it under stress is connectivity. I want to be connected everywhere.
Yeah.
Right? I don't want to have a black spot in my connectivity of the solution. So it will put stress on the network in terms of, I want guaranteed connectivity wherever I am, which I know with the network coverage we have is great in the UK, but it's not perfect. So I think we will see that resilience grow in terms of coverage.
Yeah, there's certainly a lot of work being done to look at how we can expand the network and how we can provide those wider services. Now, when it comes to the practical application of wireless technology, we're all familiar and in some cases slightly addicted to our phones and the internet. But what other wireless technologies are you seeing emerge, and what kind of devices are we going to see in use in our homes in the future alongside this smart metering technology?
So the smart metering technology, absolutely. I mean, to me, it's the base level that we're now seeing there, and then we're going to see connected energy within the home. So we already see, and we talked about EV charging points potentially being connected to manage it. We see, Nest is a classic use case for energy management within the home, but also health. So the usage of managing energy and monitoring energy the best use case, I think, was in the northwest, where we saw dementia management of patients. Dementia patients forget to do things, but people are creatures of habit. They do the same things day after day. So you can monitor energy usage and determine something didn't happen, there's an issue. And that will potentially help elderly healthcare, as an example. But it goes way beyond that. To me, the usage of the network for the smart meters will go beyond the home. And we are starting to see this in the emergence of smart city technology. Putting a communication technique on your bin, so you know where the bins are in order to put them out, right? So it's bin day. Traffic congestion. So smart cars, which will be tracked. You can then point cars to different car parks based on usage, because you know which car parks are full and which are not. And actually, Qatar in 2022 is going to use that technology for the World Cup. And other things, we see actually health. So COVID has brought that to the fore, right? We're all very comfortable now to have an NHS track and trace app on our phones, and we're happy to be tracked to make sure that we don't fall ill when we can avoid it. So communication and connectivity is going to be everywhere, absolutely everywhere, and we're not going to get away from it. And we will see 5G clearly coming along now. So 5G use cases are phenomenal in what you can do with the extra bandwidth, extra communication. Autonomous vehicles using 5G to help as an example right now, how that will impact our lives. And I'm sure we will find 5G use cases within our home as well.
I have lots and lots of technology in my house, and not all of it connects very well together, I suppose. So I'm very excited about the future from that point of view, in terms of building on the wireless networks that we have, building in 5G and enabling that speed and that bandwidth to be able to increase, so that we can have more of this technology. Not everybody is that keen, though. Do you think there's going to be a lot of challenge to encourage people to use these kinds of technology?
So I think there's always going to be a portion of the population which is uncomfortable with technology. There is always going to be that. But in reality, it is becoming so omnipresent, if you like. We depend on it so much that I don't think it's going to be an issue. I think what we will see as technology emerges, though, is we're moving to a much more standards-based technology, where we're moving away from proprietary radio communications to something that is much more standards. So if you look at IoT and the move to 4G, either narrowband IoT or LTE Cat-M, they are replacing some of the proprietary technologies that we might have seen in the past. That means we can actually have multiple devices connecting using the same communication medium, and that just expands the capability that you can do. We move away from siloed use cases.
That's the really exciting part, isn't it? Bringing all of those technologies together that can help us in our everyday life, but also through our life as well. And as you rightly pointed out, the work that's going on to use things like smart metering to help dementia patients in their homes is a really wonderful use of this sort of technology. Rick, thank you so much for joining us today. I have really enjoyed hearing about the work that you've been doing and actually the application of telecommunications and wireless to our everyday life. And maybe I think we'll pay a little bit more attention to that little box in our house in future. Thank you ever so much.
Thank you.
That's all for this month. In the next episode, we will be discussing equality, diversity and inclusion across the engineering sector, how ethnicity, culture, gender and sexual orientation affects the way in which engineering is perceived, and the barriers engineers from these diverse groups face, and their aspirations for a more inclusive industry. My guests include Dr. Shinny Samara, Carly Nettleford and Dr. Mark McBride-Wright. They will discuss the IMechE's Case for Change report on ED&I, published earlier this year. And past President and Chair of the Diversity and Inclusion Committee, Isabel Pollock-Huff, OBE, will share her thoughts and hopes for a more diverse engineering community of the future. You've been listening to Impulse to Innovation, the Institution of Mechanical Engineers podcast. Thanks for listening. We'd love to hear from you, so if you'd like to share any news or any feedback with us, then please email us podcast@imeche.org. All the information on this episode can be found in the episode notes.